Hi, and welcome to today's Tech Talk about anonymous tokens in the Norwegian Smittestopp. It's a GAEN tracking app. I'll get us started today's Tech Talk. My name is Martin Rück. I'm a senior architect at Netcompany. I've been with the company for 4 years now. A little more than 4 years. I've been working on various projects, mostly actually all of them in the public realm. So now I work with Authorization, and most recently I have been working on the two GAEN tracking apps in Denmark and Norway, Smittestopp and Norwegian Smittestopp. So let me introduce you to what we're going to talk about today. First, I'll give you a brief introduction. Then we'll be talking about how GAEN tracking app works in general. We won't go into too many details, but it'll be enough for you to understand how a national app is built. Then we'll talk about token-based authorization, go a bit into detail with this, so you'll understand how this works and specifically how it works in the Norwegian app. Then we'll look a little closer into FHI's GAEN solution and how it's built. And we'll look into Smittestopp infrastructure and in particular an issue that's related to this infrastructure and which in turn led to the introduction of anonymous tokens in the Norwegian solution. We'll look into the community contribution and how it came about, and we'll revisit the infrastructure so you'll see how it works today and how this contribution from the community was added to the solution in a collaboration between the contributors, researchers, FHI and Netcompany. Then we'll have a brief hands-on session. I will show you how you can set up a backend that issues anonymous token, and then how you can use it in another backend that accepts it. We'll be using Postman to post the request with the anonymous token. And then short questions. So introduction. Today's talk will be about general GAEN applications, Google, Apple exposure notification, specifically security in the Norwegian Smittestopp application, the collaboration between FHI, researchers, community, and Netcompany, and do-it-yourself. So this is overall, these are the topics that we'll go through, and which will also ensure that you'll have a few takeaways. So it'll be a little bit technical. I hope I fit the right level of technique. I know it's a tech talk, and I know you like to dive into all the nitty-gritty details, technical details, and I hope I give you enough for you to continue. So, in general, how does a GAEN tracking app works? This is general for all the national apps, I would say. So the blue area is the national app that the projects I've been working on, the Danish and the Norwegian. This is the code that we developed, and it interacts with the GAEN Google Apple exposure notification framework, which is installed on the Android and the Android phones and the iPhone phones. So this is not something that we developed. This is something that's pre-installed, and it exposes an API which we use, and then the national app can use the functionality of sharing keys, which is done via Bluetooth, and it just happens, in a black box, so to speak. So you get the key from the GAEN app, the GAEN framework, and the user then shares it with or sends it to the backend, or the app sends it to the backend. So this is in general how it works. So when two people interact based on a certain configuration, then they share keys, and these keys are then, if the configuration says, for instance, you have to be close to each other for 13 minutes, let's say, then you have been in close interaction, and the keys that are shared will be a potential, have potential for an affection report. So, and then the app will share it with the backend, and then the backend will share it with the European collaboration, and EFGS, as they're called, will then send it to the other participating nations, and in that way, the exposure notification will work across borders. In this case, in Europe. So, token-based authorization, in all its simplicity, works as follows. So it's the backend that has to be protected. So we protect this with something that the app or the request should contain in order to be allowed to post information to the backend. This is done in this case via token-based authorization, and in all its simplicity, it is a header value. It's authorization header, which has a certain format. In this case, the bearer. It's something a lot of people is quite familiar with, so it should be fairly easy to also to familiarize yourself with if you don't know about this. Just Google authorization header bearer, for instance. Also, I added the link up here, so you can go to FHI's Git repository and go into the backend, and you will be able to see the code that I show you now. So the backend is protected with something that inspects the request header and decodes the token that's sent in the request. In this case, it's C#, .NET Core. This is the way it's done in C#. Of course, it works in many different languages, or in all other languages that you write a backend in. But in general, it works the same way. So we have authorization attribute, which contains this. This is the class, and in a method in this class, we inspect the request header, read the authorization header, and then we just simply ensure that we actually have an authorization header and it contains the Barotoken. In case it does that, we obtain a token. This token is then sent through the code that you'll also be able to inspect yourself. At some point, it is decoded with a certificate, and the class here will then grant you access if you have a valid token. Now, this can be done in basically two different ways. You can share a private key, so the one who issues the token will use the private key in all cases to encode it, and then the receiving end could have the private key if they the two backends it is able to share this key securely, of course. Or you could do it with the private public key, and then just decode it with the public key. So this is also I mean, this is well-known knowledge. So also, if you don't know about this, it's many great articles explaining how this works. So let's say you have a valid token and you're granted access. Then you can post your the information that's contained in your request. Take a look at the code here again. This upload keys authorization attribute is it's a very simple class. It contains one method that's very easy to read and understand. And of course, once you dive into it, a lot of interesting stuff is going on. But you'll be able to see how we handle this. So let's just talk a little more about the Barotoken. As I said, this is a well-known information, and mostly you'll go to jwt.io, and you'll be able to see how a Barotoken is built. We have a header, we have a payload, and we have a verify signature part. And so this is the payload is what is interesting. You'll share information and you'll create claims in the backend, and that authorizes the user to do certain things. Now, you shouldn't share secret information here. It tells the backend the user having this token is granted access to do this and that. So if you dive into the code, you'll be able to see that we actually read the token using Microsoft the framework, and we split the comma, as you can see here. The colon coding is the three different parts split with not a comma, a period. So we read it like this, and it's all familiar when it comes to the Barotoken. However, we do not use, if you dive further into the code, where we ask, is the token valid? If you see this validate token, you'll see that it returns a claims principal, which in turn contains an identity object, as far as I remember. However, we don't use this. So this is in this solution, it's simply just an access token. It's issued by an authority, and it's encoded with a certificate. We receive it, decode it, we ensure that it's valid, it hasn't been used before, and so forth. And then, if it's valid, we grant access. Now, anonymous tokens, essentially, they're the same, they're just anonymous. Oh, that's a spelling error, sorry about that. So essentially, it's a nonce. It's an arbitrary number used only once. And it has, in our case, it has this structure. Also split with a period. But it's not a JWT token in the sense that you can decode it with JWT or in JWT.io. It's just consider it as an arbitrary number or arbitrary string that will grant you access if it's valid, of course. This is a picture from the math, or illustrating how the anonymous token is generated. I just like this picture, and it gives you sort of an overview of all the small steps that's a part of actually building the anonymous token that we use. We get a little bit back to this, and then I'll show you where you can find it. And if you're really interested in this, you can dive into all the math, and you can read about the protocol that inspires the contributors in building the code that is used for this. So lots of interesting stuff. And of course, you can also just look at the code. It's published under MIT, the FHI part, and it's all in GitHub. And if you want to look more into the anonymous tokens part, go to this page and enjoy yourself. So the FHI's GAEN solution, Smittestopp Norway, it's built with quite a few parts, and the parts I show you here is the essential ones. And so the documentation is where you'll find information about how this is built, or how it was created, how it came to be. The verification solution is where the tokens are issued, and they work together with the Norwegian IDPs, identity providers, and also EMSIS, the Norwegian health organization that carries out all the tests and holds information connected to the identity of the person as to whether the person is tested positive or not. We'll also get back to this. And then we have the Smittestopp backend and the Smittestopp app. So the app is the one downloaded on the phones. The backend is the one you saw that interacts with the European servers, and is the part that shares the keys, verifies, and so forth. So the Smittestopp infrastructure, again, this is a very simplified picture, but with enough details to give you an understanding of how the flow works. So here to the left, we have a person who goes to a test center and unfortunately is tested positive. We then, this is EMSIS, which then holds information about this particular person that has an identity in the world, of course, but also has a digital identity. And this is taken care of by the Norwegian health organization. Then the user picks up his or her app, logs in. The app will redirect the user to the verification solution, which in turn will go to the IDP, where the person will log in, and the IDP will return an ID saying this is indeed the user. The user is indeed who the user claims to be, and the verification solution will then go to the EMSIS and with the ID and say, is this user indeed been tested positive? To ensure, of course, that we don't have false reports of infection. This would be very bad. And then we have the verification solution then issues an access token, which is returned to the app, and the app can then use this access token to post the temporary exposure key, or tag for short, to the backend, which then decodes the access token, validates it, and stores the key in the backend. We see here that the access token is placed in the verification solution and also in the backend. And this is the issue that was addressed in what I refer to as issue 4. And this is what we'll get back to, how introducing anonymous tokens changed this picture. As I said, this is a simplified picture. I mean, the Smittestopp app and the backend and the whole infrastructure there is owned by FHI, and you'll find it in FHI's GitHub repository. I only disconnected these two to indicate that, technically speaking, it is in different physical servers. So they're. I mean, we communicate together, but they are not in the same place, even though they are maintained, owned by the same organization. Yes. So issue 4, when the Norwegian GEAN app was first released in a version 2, researchers from Norwegian university, I believe. They analyzed the application of the whole solution, identified a number of security issues, and then wrote an article about it, and also inspired by some work that other researchers had done and a private company had done, developed a way to address these security issues. As you can see, it's Smittestopp 2. So it's the second version of the Smittestopp. It's not the same code base as the first one, because the first one had some, it's criticized for having some security issues, which then was addressed in the second one. And then in turn, through these contributors that we'll dive into a little bit further, was actually made even more secure. So the 3 attacks that they identified, I just listed them here. I won't go into detail about it. Unfortunately, the article is in Norwegian. So if you want to dive further into this, yeah, you'll have to speak Norwegian, unfortunately. However, I will identify like the key security issue that this solution addresses, and that you'll be able to sort of pick up and use in your own solutions. They write here, I translated this is in Norwegian. We emphasize that the scenarios outlined, so the 3 attacks here, are not necessarily real vulnerabilities. Our analysis is based on a methodology where we assume that several people are able to interact in order to uncover information about one or more targets, but without evaluating whether such a collaboration is realistic in reality. Yeah, so I mean, they identified security issues, but they also note this might not be necessarily be something that you can actually carry out these attacks. As they write in one of them, a very resourceful person can, by use of his or her own implementation of a GAEN app without using GAEN, note what keys are being shared, who these keys come from. So in the wiki for the wiki I posted an address to earlier, is written, we note that the process of masking the seed makes it impossible to correlate the token, so the one that we call AT, with the randomized token, which is the anonymous token. So this is essentially, this is the essence of what this contribution gives us. So I just want to draw forward these attacks from the possible attacks, but also say that this is not what you should be focusing on. You should realize that what this solution gives you is a mechanism to disconnect the access token, the original access token, with the anonymous token. So now I'll talk a little bit about how this community contribution came about, and how it was sort of the history behind this. To begin with, this researcher, as you saw earlier, posted an issue in the documentation repository, and attached the article, and also this Smittestopp 2 village.pdf is the math behind it, and it's in English as far as I remember. And this was where it sort of started. In collaboration with Henrik and the repo Anonymous Tokens, they wrote a short implementation of this protocol and in Go, and Henrik then translated it to C#, which you can find here. And then Johannes, he picked it up, and he actually wrote the the code that turned into a pull request, which was then incorporated in the solution. As you can see, conversations, 53 comments, and 13 commits. May not be a lot, but I mean, there was a really positive and constructive discussion when this was first added as a potential security improvement. So if you want to dive into how this came about historically, this is where you want to go to the conversation in the support anonymous tokens pull request 25 in the backend repository. It's all in English, I believe, and you should be able to follow along. I forgot about that. Yes, so let's get back to the Smittestopp infrastructure, revisit it, and how this how this contribution was implemented and added to the infrastructure of the whole solution, and made anonymous tokens a part of the solution. So as you can see here, we expanded the traffic or the flow between the app and the verification solution a little bit. So the app enables anonymous tokens and is then able to contact a new endpoint in the verification solution, and using this access token actually obtain a anonymous token in the response. And we now see that the access token here is not stored over here in the backend. Here we have the it's not used in the backend. It's here we only have the anonymous access token. As we saw earlier, the anonymous token is in this case is basically just an access token, but it has been anonymized through these the flow that I showed you earlier in the picture. So and if you want to dive into the app code and see how this works, I'll just give you a brief introduction to where you should go. When you post the exposure key to the backend, the app, as you can see here, asks, is the anonymous tokens enabled? In case it is, we decide to use the request, the anonymous tokens in a request. Further down, for actually posting the tokens to, or the keys to the backend, we request this anonymous token. And further, if you dive into how this get anonymous tokens async is all wired up and put together, you'll see that we actually use the access token over here and add it as an authorization header using the bearer, the well-known bearer key. So, or it's not a protocol. I forget the word. Sorry about that. But anyhow, it's well known, and it should be quite easy to get yourself familiarized with if you don't know how it works already. So let's see how this works. First, if you download, as I said, the code is available on GitHub, and you should more or less you could get started with your own implementation of anonymous tokens by just cloning the verification solution and then fire it up in Visual Studio, and then in particular go to this unit test and run it. And this is what I'll be doing now, or at least I'll just show you how it's done. So in this anonymous tokens issue test here, you can read through all this code, and you can sort of see how it works. As you can see here, I installed a certificate on my local machine, which is then also used in the Smittestopp backend. So this is where we, in this case, in my environment here, I use the private key both places. So I have the certificate installed, and I use it in both solutions. This could also be realized in your own setup, or as I said, you could use the private public pattern. It's up to you how you would do it. I just use the private because yeah, it's easier. Yes. So not only is it easier, it's also how the code is designed. So yeah. Yeah. So if you want to obtain a anonymous token, you simply just debug this unit test, and I set a breakpoint here. And hopefully it's always interesting when you do a live session. Yeah, so now you'll be able to inspect the encoded token and copy the value, and yeah, you have a valid anonymous token. I prepared something at home, so I added it to the header, and I created my object here, the JSON object with valid values, and hopefully when I press send to my localhost development environment here. Oh, let me just briefly run this just to verify that we don't have any new keys in. I don't have any new keys in the database, and also we don't have any new access tokens. Just to verify that. So we send it, and oh, sorry, forgot. We should also, of course, start the solution here. Let me just get back to the PowerPoint presentation. So this is where you find the code here, and yeah. So we're now in the backend. Sorry about this. I should have shown this beforehand. So if you download the backend. Yeah, so if you want to experiment with this, all you need basically is the verification solution, clone it from GitHub, the backend solution, clone it from GitHub, and then Postman. And you should then make sure that you have multiple startup projects and start the API and the jobs if you want to see the whole solution working. In this case, we are only looking into the API. So this is how the body is supposed to look like. And we'll be looking into this attribute that I showed you earlier. So now we should be able to, just 1 second. Yeah, so we have the why isn't it started? Oh, yeah. Now I started here. Yeah, just while this application is starting up, this is the repository that you should go to look over the code. And I believe I showed you an article from a Danish newspaper. I apologize about that. It's not intended. So yeah, this is the hang file. We're not really interested in that. Just show you the swagger. Let's hope it reloads. Is it? I don't know what's going on. Here we go. Yes, so the solution is now up and running, and in Norway we only support version 3. You'll see this in the here, the URL. Anyhow, now we can press send, and hopefully we will hit the backend. We did. So as you can see here, this is the class I was talking about. Very short. I mean, of course, a lot of things happens under the lid, but I will show you where to go to familiarize yourself with that. So we step through here. Yeah, so we read the authorization header, inspects it, see if it's a bearer. It's not, and we see if anonymous token config is enabled. It is, and we read the anonymous token, and we remove the anonymous, and then here the interesting part is sorry, yes. Okay, so this is where you want to dive into if you want to see how the code actually works. As you can see, a lot of things is happening with decode, and luckily our anonymous token here is valid, and we will receive a 200 response, hopefully. Yes. So I was actually able to post my my key to my backend, and let's just verify that it actually is here. It is indeed. And as you can see here, this is UTC. Yeah, the time here is 8:30, and it was, and since I'm sitting in Denmark, it's UTC +2, and so this is the key that we created. And we see that we stored an anonymous or a token in our JWT token database or table in the database, and this will be used to ensure that we now have an invalid token. So let's just step through this again. And we should receive an false invalid token. There we go. That was all. Where is it? There. Yes. So yeah, this showed you how what an anonymous token in this case is, how it is used in the Norwegian Smittestopp app, and how it works. And you should with fairly small steps be able to use this in your own setup. Of course, there's more to it than that. You'll have to set up the database. You have to create certificates. I suggest using the internet web service server on. If you use a Windows environment, create your certificate there. This will make things easier for you. It's easier to use OpenSSL, I believe, or maybe not easier, but it gives you a better idea of what you're actually creating. But use the ISS. It's also fairly good, I suppose. You can always inspect it once you install it. You'll have to grant access to the certificate with the user running the backend and the verification solution and all that. But this is also well known in when you mess around with certificates. So it shouldn't be something that's too surprising. But of course, it's whenever you get yourself involved with certificates, you could be entering a world of pain. But mostly it's fun, and it's actually of course, I mean, it adds security to your solution, so of course you should know this. But always a lot of fun stuff when you have to get it working. So the key takeaways should be how I added two GAEN solutions work, because the Danish and the Norwegian solutions are quite similar. I mean, in general terms, we haven't dived into all the gory details. That's another talk. And then an understanding of token-based authorization, both the well-known bearer and how anonymous tokens is used and implemented in this particular solution. And then a tale about successful collaboration between researchers, private contributors, and the Norwegian health organization, and then a private company, Necompany, and how we actually added an extra layer of security to the solution by listening to each other, debating, having a constructive debate on GitHub, and then in the end accepted the pull request with a few small changes. We also changed some of the code that was already there, in sort of to integrate this new attribute with an existing one. It's a beautiful story, I think. And it just goes to show that if you share your code, if you listen to all the talented and intelligent people out there, you're actually able to improve such a thing as security, or just the general quality of your code, or your solution in general, of course. And then finally, enough to get you started using anonymous tokens. Personally, I think it's been a lot of fun working with getting up and running, talking to, in this case, FHI, which was the one I worked most closely with, and solving all the minor problems that you always run into, and finally just getting it to work and testing it, putting it into production, working together with the app team and their implementation of it, and just to see it actually work out there. And one thing I may have forgotten, you should also walk away from here with enough information on where to find the different information, where to what particular piece of code you have to dive into in order to look at the code behind what is actually going on, and sort of take it away and use it in your own solutions if need be, and if you want to. Now, as the questions and comments, won't have that here, but if you want to hear more about this, you're more than welcome to reach out. My email address is here. And if you have general questions about Netcompany, you should write to the info address. As I said, feel free to reach out. Also, if you decide to use this and run into some problems, reach out. I'm pretty confident that I have seen most of the problems that you would run into, and would be happy to share that with whomever needs it. And if not, if you don't decide to use it, dive into the information behind how the anonymous tokens was or is developed, is designed in this particular solution. It's, as I said earlier, MIT license. It's right out there, and dive into it, familiarize yourself with it, read the math, read the code, get a good understanding of why this access token and the anonymous access token, as I call it now, or here, is actually disconnected, and you won't be able to interpret the one from the other. With that, I will conclude this session, this tech talk. I hope you enjoyed it, and just wish you a happy summer in this case. You might not see this during the summer, but happy coding then, at least. Happy designing your solutions out there. And yes, that's it. And thank you for watching.